I would like to welcome my friend Paolo Lucente from pmacct.
So good morning, everybody. I was not expecting a real podium here, so this is getting me a little bit shy, but and I am on camera. So hi, camera. So good morning. I'm Paolo Lucente from the pmacct project for half an hour of Italian English, and I would like to present to you today a little bit about pmacct. If you don't know what is that about, it's a tool I wrote almost more than 10 years ago. And to speak also a little bit about pmacct in the context of telemetry, streaming telemetry with the capital S and capital T. So who knows about streaming telemetry? Who heard about it? One, two, oh, very good. And who is actually playing with the streaming telemetry? So, oh, okay. We have also the half and half. Okay. So this is going to be bloody cutting edge today. Great. Okay. So perfect. So who I am, as I was saying, I am Paolo. I was working for a service provider for many years. And I'm full of former colleagues today here. That's great to see, and shows how many years I spent in this beautiful country. And after that, I was working. I am working for vendors. Actually, only one vendor that got acquired and then acquired, the boxes of acquisitions. And I'm now, as a result of that, working for a well-known vendor that starts with the C and ends with the O, which I'm not representing today. And I essentially worked for, with IP accounting and collecting traffic statistics forever, essentially. And that's why I stumbled at the end of the 90s with one of the first incarnations of NetFlow. And I've also been using, all of these in, operators for all my time at operators and now at vendors. And I've been always an advocate of NetFlow and collecting traffic statistics, and not only for security purposes. It means that, maybe today is something a little bit that we give for granted, but if you think 10 years ago, what people was doing with NetFlow and what you would read on every Terrain conference and things like that was, NetFlow as in security mitigation, detection, DDoS detection, and things like that. But with NetFlow, with the collecting traffic statistics, you can do much more. You can cover a lot of other use cases, including traffic engineering, peering. You can do capacity planning, peering analysis, and things like that. And my interests were always revolving around all of these things, and I stayed always away from security. So what is pmacct about? It's that box in the middle with the angry octopus logo. And I can explain you privately why it's angry, the octopus. So it's sitting there in the middle, and you see it's connecting several things together. That's why it's an octopus, right? So in the upper left side, you see in red a few boxes like streaming telemetry, lib pickup, NetFlow, IPFix, and SFlow. That would be, traffic capturing methods or, data sources. And then you see on the bottom left part in yellow, things like BMP, BGP, IGP, and maps. And you see a bidirectional arrow, meaning that you can definitely import all of this data in pmacct. And when I mean import, I mean establishing BGP sessions, BMP sessions, or an IGP peering, let's say. And what you can do is not only receive this data, but also correlate the data that you receive from the network, like the NetFlow with the BGP or the NetFlow with the BMP, for example. And then you can save all of this data, correlated or not, to some backends that you see in blue on the right-hand side. So you count among the backends relational databases like MySQL, Postgres, SQLite, NoSQL databases like MongoDB and BerkeleyDB, flat files, brokers like RabbitMQ and Kafka, and memory tables. And of course, you have other use cases by which essentially you can let pmacct work as a probe, so you can export sflow or netflow traffic, or you can replicate, let's say, netflow or sflow traffic. So some simple use cases around pmacct are, this. So you can use pmacct to let's say, capture NetFlow traffic and write it to flat files, for example, for forensics or use cases like that, so where you have so much data that you don't want to store them, for example, just in a relational database, and maybe from flat files then you want to import into some other backend. You can replicate sflow, right? So you receive sflow and then you replicate it to third-party collectors doing their business. Or, for example, you can collect BMP statistics, so BMP events and routes, and dump them onto Kafka buses, where a consumer that you may write can consume this data and do whatever you may like with that. I don't know, analysis of flappings, or or flapping routes, or route analysis of if any of your peers is hijacking routes or anything like that. And then, of course, you can work also, pmacct can work also as an exporter of data, so you collect lib pickup, so you really packets, you sniff packets on the network off of a switch or whatever, and then you can, build an IPFix packets out of it. So you consolidate packets into flows, and then you export it with a well-known ITF-based protocol like IPFix. And then, of course, you can do also something more complex than just that, right? So you can collect the NetFlow and IPFix, and then you can replicate it to third-party collectors, and at the very same time, you can also correlate that with BGP. And then what you can do with this NetFlow and BGP, you can write it with two different aggregation methods, to flat files and to MySQL for different use cases, like flat files for, I don't know, forensics, and MySQL for reports that then you want to show through a dashboard, for example. And at the very same time, you can take the BGP, and to do some analytics against it, you can dump or stream real-time the BGP updates to a Kafka bus. And all of that, just with a single daemon instance. So what are the use cases or the usage scenarios for pmacct? You see, I divided it by, let's say, by entities, right? So there is a strong core at the center in that gray circle over there that belongs to all of these entities. But in the end, you can see, you can infer from this that pmacct is a very flexible tool. Flexibility sometimes comes with complexity, which is something that sometimes, I understand that some people make a comment that, picking it up for the first time, it's not maybe the simplest tool to pick up, but in the end, you are rewarded by a lot of flexibility. You can do a lot of stuff with it. And so some non-technical facts about pmacct. As I was saying, it's more than 10 years old project. I think it's 13 years, if I see on LinkedIn. It comes with an awful name. I'm totally conscious about that. I'm not good at marketing. And then it's free, open source, and independent, which is very important, and it's under active development. If you go on GitHub, I think the last commit on GitHub was yesterday, and it's not this morning just because I'm here, and it's 9:30, and I am Italian, and 9:30 doesn't exist on the Italian clock. And I have to say that, it's under active, and speaking of GitHub, we have to say thanks to Job, who imported overnight almost, the whole work and the CVS repository into GitHub. Thanks for that, Job. And innovation is being introduced, meaning that it has never been my goal to try to, to to reinvent the wheel or to copy what other people were doing and things like that, but it has always been my goal to do new stuff and also to hear at the many people in the service provider community and then come with things that are of interest, that are not existing, and for which there is not a free open source solution. And as a result of that, I'm very happy whenever, either commercial products or other free projects, they are copying what PMSCT is doing. It's very, it's very nice to see that. And then it's also being well deployed around, also at large service providers. And, I come from the service provider community myself, and so I, let's say, hope, that the tool is has very strong ties and with this community. So it is like that today. It's thanks to many of you also in this room if the tool is what it is today. And if I was a vendor, I would say I would like to meet and exceed your expectations every day. So, but speaking about a little bit more technically, a few, features of PMSCT are that it's a pluggable architecture, so you have really abstraction and APIs and libraries inside the PMSCT, so you can plug new data collection methods or new backends very easily. And correlation of data sources. So, like I was saying, you take, so things are not siloed, so you can really take NetFlow and SFlow and correlate it with BGP, BMP, or streaming telemetry. And then the other thing is that you can, and of course you can provide external maps, and then you can, correlate maps with the data by issuing tags or labels. And then you have pervasive data reduction techniques like aggregation and filtering, because NetFlow or SFlow data, it's a lot of data, so you have to aggregate it somehow, and filter and split and do all the juggling around in order to keep a data set manageable. And so the other key fact is that PMSCT was really conceived with the idea that you should collect things once, things being traffic or being BGP routes or whatever, only once, and then do as much things as you want with it, right? So it's perfectly possible, like you saw in the visual slides a few slides ago, that you can have two different aggregation methods and export to different backends, and all of that, only collecting traffic once. And then at the very same time, you can also do, while you are correlating stuff, right? So for example, you collect BGP and BMP or streaming telemetry. While you use that for correlation against traffic, you can also do analytics, against it, right? Meaning that you can really export it. So all of this information is not just kept in memory. You can really export it and do whatever kind of analysis you want with it. You can do it, you can stream things in real time to your consumers or applications, or you can do dump at regular time intervals, which in some cases like BGP offers also state compression, which is depending on the goal of your project or the kind of analysis you want to do, it may be wanted or not wanted. Now, jumping into streaming telemetry, and I will use a definition, or I captured in 3 points a definition from the Cisco ISXR telemetry configuration guide. And why is that? I mean, openconfig.net should be the place where you should source information on what is streaming telemetry in a few concise words. But I felt that the description at openconfig was a little bit metaphysical, even for a very good audience like this. And so I thought, to do something, to take something more practical, which was, the Cisco ISXR configuration guide. So in other words, I mean, if I should even further summarize and translate you what is written over here, streaming telemetry is, would aim to be on the longer term, a replacement for SNMP, where instead of polling information from the routers, you are streaming this information from the routers, right? So you don't have to poll, so a collector, it's really a push technology, a little bit like NetFlow and SFlow, right? And that is also why you see that, it was very very intuitive for a project that was in NetFlow and SFlow also to grow into this kind of area. So what would be, use cases for PMSCCT with streaming telemetry? First of all, you have a new daemon, which is PM Telemetry D. So you collect a streaming telemetry, and then you can, dump it at regular time intervals to flat files, or you can stream it again real time to a Kafka bus. Or you, as part of NFACCTD, this is a slide that is a little bit for future reference. I hope to get here by the end of the year. So still you can do the usual things like the slide we saw some time ago where instead of streaming telemetry, you had BGP. So essentially, you can use streaming telemetry to correlate NetFlow data against, right? So what would be an example of, the use for correlating streaming telemetry with NetFlow? It's good to have a practical example. So it would be so we said streaming telemetry is a replacement for SNMP, for example. And so you can collect interface counters, right? So the same interface counters with the IF index and input bytes and output bytes and things like that, right? So imagine you are collecting all of that. And then you are also collecting a NetFlow traffic, sampled NetFlow. Now, if you ever collected, on a very large scale sampled NetFlow, you realize that NetFlow always tends to undercount. Even on the best of the best platforms, it is undercounting always compared to SNMP. Why is that? Because it's a sample technology, but also because of bugs, throttling, and things like that, right? It's always undercounting. Now imagine that you can normalize the NetFlow traffic so to match the SNMP, so the streaming telemetry, so the SNMP IF indexes and things like that. Then you can work out like rescaling factor on a per interface basis, right? And then by doing that, you can rescale your NetFlow traffic on ingress, for example, so to match, so you can pump it up a little bit so to match the SNMP. This is, a very simple and naive use case for correlation between a NetFlow and streaming telemetry. So where correlating a NetFlow against infrastructure data can be useful. But of course, you can imagine there is a lot more of use cases for that. And then now I would like to start with a rant, which will drive us pretty much up to the end of the presentation. So most of the streaming telemetry part, it will be a rant. But let's start from, putting things in order. So far it has been a very, exciting experience working with the streaming telemetry. So I am one of those that is actually playing with that. And I'm playing against Cisco and Juniper and Arista boxes. And so it has been, a very, experience in this enchanted world where things are not standardized and, don't just work out of the box. And it's been very cool. It brings me back really many, many years. So, but why is that? So, because, what is the problem currently with streaming telemetry? So, first of all, we said there is this open config kind of, organization or consortium or association or whatever, which is defining things. And open config, it's very true. It's defining things, but pretty much in the area of data modeling. Data modeling is cool, right? So who doesn't feel cool nowadays if you don't have yang on your mouth, right? So everybody wants to speak yang and whatever. But unfortunately, the sad reality is that the bits and bytes have to migrate from one box to another. Right? Still, you have those very old problems that you may neglect as much as you want, but you have them. So, bytes don't just migrate spontaneously from an exporter to a collector, and then a collector doesn't just magically decode these bits and bytes. And, and things like that, if you follow a little bit the people that say that data modeling is cool. By the way, I think it's cool, but they tend to refer that all the rest is really details, right, in between quotes. And continuing, building on the plot, right? So I have myself, deep roots in the service providers. As I said, I worked for a lot of time in service providers. I go to pretty much every RIPE meeting for the past few years, and I'm at NLNOG, I am at NLNOG, I am at very national, a lot of national NOGs, for a brief time also at peering and peering forums as well. And I always believed into, the mantra where, ITF has a disconnect with operators, and we should bring those worlds together. I think a lot of steps forward were done in the past few years, and that is very great. But now, if you look at what happened with this open config thing, it is very interesting, right? So you have all the logos of the people involved with this open config, association initiative and whatever you have over there. And as you can see, I mean, it was really conceived like that, that it is, really operators and vendors should stay outside. But is that correct? Or is it just a little bit of revenge? So you take any two logos in that in that page, or especially when you think about the very big guys. So there is any. Let me just spit a few names randomly, right? So is it any better putting in the same room and trying to agree stuff, Google and Facebook instead of Cisco and Juniper? Do we really have a gain? Is anybody gaining for that? I'm not extremely sure, to be honest with you. So a little bit of, more things about streaming telemetry. I mean, I leave to you as a homework. You remember 2 slides ago, I was saying about the spontaneous migration of bits and bytes, right? And then I was mentioning details. So, take just these keywords, right? Like gRPC, netconf, resconf, JSON, Google protobufers, Avro. We can add Thrift. We can add several other stuff. And then, you understand, I think, when what we refer as details. So you really to make a data that is being very well modeled migrate from an exporter to a collector, you need subscription methods, you need the protocols, you need all of things like that, and you can just deem that as details, right? So you understand why they are deemed as details, because there are some things that cannot really be agreed upon by, the players in that room that we saw in the last slide. But, I mean, are we really benefiting from that or not? So a fun fact is that if you log into any of the Arista, Cisco, or Juniper boxes, and when you see how things are being exported, you see, like I was saying, encapsulation like JSON or Google protobuffer. And the nice thing about Google protobuffer is that, so the way in which it works is that in order to ensure a hard typing of the schemas, you have to really so you have a protocol file, so a definition, a schema definition. You compile it with a compiler, it spits out some code, and then that code, you should include it in your source code. But at least, I mean, I was convinced for many years that, when you include the source code into another source code, then licensing is kicking in big time, right? So what happens to this code? So who owns it? Who is the license? How things are, working over there? I think there is, within the same company, there is no problem, but we are speaking streaming telemetry, so by definition, we are migrating information from, possibly from one company to another. One company defined something, and then there is another company that is receiving the data. So I'm not really sure. I think there is a little bit of a gray area. And then still speaking about a quote from the industry, so from David Barroso, that currently is at Fastly, previously at Spotify, who is playing with streaming telemetry. I have a very nice quote that I got last time we were speaking about streaming telemetry, which is, let's hope they don't turn out into the enterprise MIBs of the 21st century, right? And I think it's very, it's a very good quote. And of course, all of this is, still with the streaming telemetry that has really little adoption. So people didn't really start playing yet with streaming telemetry, and there is, quite some concerns. So I conclude with a question and then with a summary. So my question is, how is, a peaceful gathering of vendors, right? Different, and when I say different, I mean different in any words, than, an operator's only working group, right? So like the open config. I'm not sure. And of course, there is this mechanism kicking in, right? So you have the vendors, and I say that the vendors are standing, their arms while, the operators are meeting. Why is that? Because, of course, the vendors want to sell to the to the operators. So if they are defining something and the operators are big enough, then there is a chance that they will raise their arms. And I say raising their arms to be a little bit elegant. So doing a summary, and the conclusion on streaming telemetry, I think that streaming telemetry has no doubt, a great potential. So as an idea of pushing information instead of polling information and things like that. But for some aspects of it, which is what we just described, so not the data models, but all the things that is underneath, the thing that people say it should just work, but it doesn't work. Really. We have fragmentation. We have just too many choices in terms of how to travel the data around. There is creativity being left, to the vendors, how to implement stuff. There is things are not very well defined. You have several equivalent choices on, many levels over there. And I wonder, and this is in the end the takeaway question from my rant, which is really who is benefiting from this fragmentation, right? And if you were, sold the idea that, the value is in data, which I agree that the value is in data and the modeling data is cool. Let's not just, and you were sold also the network automation hype and things like that. I would say let's not take abstraction as the excuse. So abstraction is there to solve, problems, existing problems and things like that, but we should not do, always the same mistakes and create even more fragmentation because we can, now automate and abstract things. The rant is finished. With that, I can leave. So, so this is many resources still about pmacct, and if you want to read anything about them. And with that, I finish. I thank you for your attention. Any questions?
We have time for one question. If you want to ask questions, come to one of these two microphones, state your name and affiliation, and then ask your question, or a short speech, of course. If there are no questions,